Welcome to this video on ionic bonding notes. So as a reminder, you should have already copied down this set of notes. I'll put the link in the Edpuzzle video if you still need it, but we've already copied this down. I'm just going to go through the notes, give you some more examples, and then in this space here at the very end is when you can write down some of the practice problems that we do at the end of this video. So ionic bonding is the attraction between two oppositely charged ions. So it's that kind of attraction that you guys have known about for a long time. We know that positives and negatives attract. This particular type of attraction, that positive and negative attraction, is called an electrostatic attraction. That's just a word that you should be familiar with. And then you'll notice, hopefully you drew this visual here as well. So we've been working with ions and making ions. Now it's time to talk about when they combine to form ionic compounds. So ionic bonds, couple of features. So reminder, metals lose electrons to become cations, nonmetals gain electrons to become anions. And the opposite charges form a strong bond. So this image here, what would happen is if we have sodium Na and fluorine, then our sodium electron is going to be transferred to my fluorine. So that would make my sodium a +1 charge because it lost a negative electron. My fluorine gained 1, so it becomes -1. And the attraction between the positive sodium ion and the negative fluoride ion would have a very strong attraction and form an ionic compound. Ionic compounds bond with one another without distinct molecules. You learned that in your Explore activity on the website. So we have to use ratios of cations to anions to write our chemical formula because they just make huge giant compounds. So for example, here we have a crystal of potassium sulfide. So the yellow is all of the different potassiums, the purple is the sulfurs, and so we counted them. If there was 14 potassiums and 7 sulfurs, we would reduce that ratio. So if we had 14 to 7, we could reduce that to 2 to 1. And that's where we get our formula, K2S1, because remember, we don't write the 1. An ion's charge is based on how many valence electrons it gains or loses. So we saw that when we were dealing with the sodium and the fluoride. If a metal loses 1 valence electron, if you lose a negative, you have a charge of +1. If you lose 3 negatives, you'd have a charge of +3. If you are a nonmetal, so you gain electrons instead, you would have a charge of however many negatives you gain. If you gain 2 negative electrons, you'd have a charge of -2. And these are just some visuals of that. So this is an example of when we lose negatives, we have a positive charge. And when we gain negatives, we have a negative charge. So this is an image that's in the chemistry resource packet, page 8. I'll link that here for you. You want to either memorize this, write it down, or write the charge trend on your periodic table. What I like to do on my periodic table is where I have my hydrogen alkali metal columns, mine right now says that there's 1 valence electron there. I like to write above that a little +1 in parentheses to tell me that, just as a cheat, if you have 1 valence electron, the type of charge you're going to form as an ion is +1. So you want to be familiar with this, and it's very handy if you do either have it on your periodic table or if you print out or are able to use this page in the resource packet. So you already drew this diagram. We used these Lewis dot diagrams that we practiced with last week to draw the transfer of electrons. So we started out here, we're talking about calcium fluoride, and I drew my calcium and my fluoride ions based on how many valence electrons they have. So on my periodic table, I can see that calcium is an alkaline earth metal. It has 2 valence electrons, so I drew my 2 red dots here. And then my fluorine has 7 valence electrons because it's a halogen. So I drew them out, drew those Lewis dot structures, and then with the arrows, I'm just showing what happens when we transfer those electrons. And you can see in this case that because calcium has 2 electrons to give and fluorine can only take 1 of them, I had to draw 2 fluorines because I needed to get rid of both of calcium's valence electrons. So that forms these ions, and you could also find these ions hopefully on your periodic table now, and we make this compound. So let's continue to practice with that. Let's practice by drawing one out from scratch. And this is something that you can draw as well. So here's a little shortcut. And if this is more confusing for you, then don't worry about it. It's just a shortcut to do the same thing that we did on the previous slide by drawing those dot structures. So for example, with aluminum chloride, our first step for this crisscross trick is to draw out our chemical formulas with the charges. And these charges, remember, are based on the valence electrons. Aluminum has 3 valence electrons, and it's a metal, so it will lose them to form an ion with a charge of +3. Could have also written out the charge itself on your periodic table. So the trick is that if we have my 2 ions written out, my metal and my nonmetal, I can drop these superscript charges down and make them into subscripts to form my compound. Now let me kind of show you the long way out over here on the side to show you why that works. So if my aluminum has a charge of +3, I'm going to draw my aluminum with its 3 valence electrons. And then it's telling me I have 3 chlorines. Okay, so chlorine has 7 valence electrons. I'm going to draw my 7 valence electrons here. What you can see is my aluminum has its 3. It's going to give 1 to that one. It's going to give 1 to that one. It's going to give 1 to that one. So aluminum got rid of all of its charges, and each chlorine got 1. So this trick is just our faster way of doing this Lewis dot structure. Let's practice again. Okay, so let's practice with number 1. So I gave you here both ions, Mg+2 and Br-. If I'm doing my crisscross trick, I'm going to drop these charges down, and I would end up with Mg, and that's a 1, so I don't draw 1s, right? And then Br2, according to this crisscross trick. Let's see if it works. So Mg is an alkaline earth metal, so it has 2 valence electrons. My Br is a halogen, it has 7. My crisscross trick told me I'm going to need 2 Brs. So I have 7 valence electrons. Let's see if it works. I'm going to have 1 of magnesium's electrons fill that octet, 1 of magnesium's electrons fill that octet. Perfect. Mg+2 and 2 Brs. Go ahead, pause here, and try number 2. Okay, welcome back. So my crisscross trick, drop these 2 down. I end up with Al2S3. Let's see if it works. Aluminum, aluminum. It says I have 2 aluminum atoms. Each aluminum has 3 electrons to give. My S, it says I have 3 sulfurs. 1, 2, 3. Each sulfur has 6 valence electrons. I'm going to try to squish these in here. So I have 2 going to this one, another one going to that one, and my final 2 going here. It works. Everybody has their complete octets. All right, go ahead and try these out on your own. Here are the answers. Hope that was helpful.